Hello everyone. I hope we are live now. Okay. So I am just sharing my screen. Okay. So in the previous session, what we have discussed quite a few interesting things. In those few of you were absent actually. The things were we have discussed mechanical equilibrium. We have discussed torque about the axis, uh, the equilibrium of mechanical seesaw problems, rod problems. We have discussed a lot of things there. So I insist you actually to go through with those lectures or with that lecture actually. So it will help you a lot. That was an important lecture. So now in today's session, what we are going to study is angular momentum. We are going to study about angular momentum. So let's start the session. Okay. So what is angular momentum? Like we have studied linear momentum. That was P is equals to M into V. Now we are going to study about angular momentum. So first of all, have a look at that. Have a look at that. Suppose there is a origin O and a particle is moving in this direction. Particle has a mass m and is moving with a velocity v like this. What we need to do, we need to find the angular momentum of this particle. We need to find the angular momentum of this particle. So what we can do, first of all, remember each and everything. First step is we will join the particle with the origin, and this line is called as position vector, is called as position vector of what? Of the particle, position vector of the particle. Then angular momentum is denoted by L, and it is defined as L is equals to vector R cross P. This is what angular momentum of a particle about a point, and this point is known as origin. This point is known as, that's what we have done in case of torque. Torque was calculated as tau is equals to R cross F. In the same way, L is R cross P. Now, can you tell me that momentum of the particle is along the x-axis, because particle having a velocity v in the x-axis. So what is the momentum? You will say P is equals to m into v. Now again, let's suppose what we want to suppose. Let's suppose this angle is theta. This angle is theta. Then how can you write this expression? You can write it as L is equals to A cross B means AB sine theta. That is R P sine theta. Let it be equation number one. Let it be equation number two. And in case of vector product, there is a direction associated. And that direction is calculated by the right hand thumb rule. By the right hand thumb rule. And I hope you know that rule from the vectors chapter. If you don't know, then you can ask me. I will discuss it here as well. So now, moving further, can you see that there is a P sine theta? Again, if I do the components here with a pen, just take a different color pen. I think this would be better. Now, have a look at that. This vector P is along this direction. This is vector P. If I take the component of this vector p, then it will be, this component will be p cos theta, and this component will be p sin theta. Now, can you see one thing? That p sin theta is perpendicular to r. P sin theta is perpendicular to r. So we can write that L is equals to r into p perpendicular. What is p perpendicular? Perpendicular component of the momentum. Perpendicular to what? Perpendicular to the position vector. Position vector of what? Position vector of the particle with respect to the origin. I think these things are clear in your mind. Now again we can write it in another way. How? These are important things. That's how we calculate. Have a look at that again. Now, can you see that this equation Rp sin theta L equals to Rp sin theta can also be written as L is equals to R sin theta into P. There is no difference in these two equations. Let it be equation number third. Now, just identify R sin theta. I am drawing a diagram again, the same diagram again for you. Have a look at that. This is our origin, O. This was the particle which is moving along the x-axis. Particle has a mass m, velocity v, and momentum p. P is equals to mv. So now, what if I say that this is the position vector? If I am not wrong, then this is the position vector r. Again, one more thing. One more thing that is needed to be described here. This is r, extension of r, and this angle is theta. That was the original diagram that I have drawn, redrawn it again. Okay. Now, if I extend the motion, line of motion, now I am repeating one word again, that velocity is along the x-axis. If I elongate this line, then this line is known as line of motion. The line along which particle is moving is simply known as line of motion. So can you see that particle is moving along x-axis? So x-axis will be the line of motion. So this is our line of motion. In case of torque, we have defined a line of action, the line along which force was acting. So now line of motion is what? The line along which particle is moving. So this is our line of action. Can you again see that this angle is theta? Then due to the vertical opposite nature, this angle will also be theta. Now, if I say that draw a line like this, draw a perpendicular like this, in fact, I have drawn a perpendicular on the line of motion from the origin. Can you identify that this distance, this blue line, suppose O and this point is something A and this point is something B. Then can you find that what is the length of this OA? OA is what? Is perpendicular in the diagram. Perpendicular is what? Hypotenuse into sine theta. So that will be R sine theta. Now can you see that R sine theta in the diagram is what? R sine theta is the perpendicular from the origin on the line of action. So I can modify this relation again. L is equals to R perpendicular into P. This is again a most important term. L is equals to what? R perpendicular into P. I hope these things are clear. Now, what is R perpendicular? If I ask you, define R perpendicular and P perpendicular. So R perpendicular is what? Perpendicular distance from origin to line of motion. Perpendicular distance कहां से? From origin कहां तक? to the line of motion. What is line of motion? I have defined already. So what you need to remember, two more things that you need to remember, that angular momentum is a vector quantity. How its direction can be calculated? Using right hand thumb rule. Right hand thumb rule is what? If you don't know, then right hand thumb rule says put your right hand finger in the direction of first vector. In the direction of first vector means in the direction of r. Curl them by taking it towards the second vector, that is p, and the thumb will decide the direction of angular momentum. Thumb will decide the direction of angular momentum. So these are the things that is to be remembered. Now, moving further, I hope these things are clear in your mind. You can ask me anytime. Okay, moving further. Now, one more time, I am saying that just watch the previous lecture as well. That is most important lecture. Okay. Angular momentum of a rigid body. Before, in the previous slide, what we have discussed, angular momentum of a particle. Now we are discussing angular momentum of a rigid body. Can you tell me what is rigid body? At the start, we have discussed the rigid body. The rigid body is what? Can you remember? Now, have a look at that. Consider this is a rigid body and is rotating with an angular velocity omega about this axis. About this axis. Now, what I want to do, I want to calculate the angular momentum of this rigid body. Can you see that? Can you say that actually the body has a lot of particles in it? A rigid body is made of number of particles. So I am just taking a particle. Suppose this is a particle. There are particle 1, particle 2, particle 3. We have discussed it a lot of times. Suppose this is ith number particle and it has a mass m, and I denotes the number of particle. M1 is first particle's mass, M2 is second particle mass. So this is Mi. What we have discussed is that during the rotational motion, each and every particle is revolving in a circular path. So this particle is also revolving in a circular path. Something like that. Clear? This is the particle. Can you again say that if we take origin here, then the radius of the particle, I am taking the ith number particle, then I am also taking the radius of the particle of the circular path as Ri. Now, students, you are coming late. Everyone is coming late. It's not good actually for you. I'm not saying because I'm just sitting far away from you, so I can't say much, but it's your responsibility to join on time. Otherwise, you will miss some essential content actually. Okay. So what we are going to do, listen to me, we are going to find the angular momentum of one particle, that is ith particle. And then for the complete angular momentum, I will add all those angular momentums. Clear? So, angular momentum of this ith particle will be, you will say, angular momentum of this ith particle, suppose Li, is equals to what we have studied, R perpendicular into P. Is it clear? R perpendicular into P. Can you see that R perpendicular is what? Perpendicular distance from the origin towards the line of motion. This particle is moving in circular path, then its line of motion will be like that. So line of motion is like that. Then radius will be the perpendicular distance. So what is this? Ri. And what is the momentum? Momentum is mass into velocity. Mass is Mi, velocity is Vi. I think these I terms, just don't get confused with those I terms. These are just the notation for the ith particle. So now Ri is here, Mi is here. Can you see that? Do you know that this linear velocity is r omega? Is r omega? We have discussed it in the previous lecture actually. R omega. Can you see that it will become mi ri square into omega I? This is the angular momentum of ith particle. For body, what will become? For body, angular momentum is denoted by capital I is summation of all these angular momentas, that is mi ri square into omega I. Anyone is there who knows this term, summation mi ri square? Who knows this term? And one more thing you should know, that each particle will have same angular velocity. That's the thing that we have discussed in the previous sessions. So what will become? L is equals to, this is what? Moment of inertia. This is what? Moment of inertia I, and every particle has same angular velocity. So what will be the result? L is equals to I omega. Now, this is the final result. What is the result? Angular momentum of a rigid body is what? I omega, where I is the moment of inertia. Angular momentum of a particle is what? L is equals to R cross P. Or what you can remember, R perpendicular into P. Now, I am going to put a question on your screen. Just try to solve it out. Just try. The question on your screen, I don't know what you think about those classes actually, but what I think that it should be taken seriously by you, because we are just discussing some important things and you are not responding. That's why we are not getting that up to what level we can rise. So please try to do. This is the same question as discussed in the lecture third. So I hope you are doing it, you are attempting it. So let's solve it. What is say? A particle having mass m is projected with a velocity u from a point P. From a point P on a horizontal ground making an angle theta. So this is the case of projectile. In fact, at first line, what we can see, this is case of projectile. What it says that a particle is like that. This is our ground, and a particle. This is the particle, and this particle is thrown. And then if you throw it, then it will go something like that. Let it is thrown from point A and reaches point B, and this is the maximum height point. Suppose C. Now, in the next line, find out the angular momentum of the particle about the point of projection. Point of projection is what? A. So A is our origin. Now we have decided, question says that about the origin, that means A is our origin. What, when it is at highest point? So particle is at highest point. What we can say, at the highest point, you must know the projectile scenario. At the highest point, particle is in which direction it is moving? At the highest point. Do you know that a particle, if it is projected with some velocity u at an angle theta, then it is a combination of horizontal and vertical motion. You all know these things, na? So this component of velocity is u cos theta, and this component of velocity is what? U sin theta. You all know those things, huh? So at the highest point, it has no vertical velocity. It is just moving in the horizontal direction. So this is the horizontal direction and it has a velocity u cos theta. Now, what we can say that angular momentum L is equals to which formula we are going to use? I omega or R cross P? Because this is a particle. And for a particle, angular momentum is R cross P. So we are going to use that formula, and simplified form, it is R perpendicular into P. Now, you need to identify R perpendicular. That is our purpose. Have a look at that. First of all, you need to draw the line of motion. Only then you can identify the line of motion, or you can identify the R perpendicular. So line of motion is particle at this highest point is moving along the x-axis in the horizontal direction. So the line of action will be like that. This is our line of, not action. This is our line of motion actually. So this is our line of motion. So just draw a perpendicular on the line of motion from where? From the origin. So if I draw a perpendicular like this, so this is our R perpendicular. Can you see that this R perpendicular is nothing but the highest point or the maximum height? So what we can write, L is equals to H into P. H is what? Maximum height. What is the maximum height in case of projectile motion? You will say, sir, it is u square sin square theta divided by 2g into P. This is what? Maximum height. What is P? P is the momentum. Mass of the particle is given as m. This is the mass of the particle. So you will write momentum as m into its velocity. So at the highest point, its velocity is u cos theta. Now, if you arrange all these terms, you will get a simplified, simple answer. Otherwise, this is your answer. If nothing is cancelling out, then this is your answer. Are you getting my point? How to identify R perpendicular? This is the main thing that we want to learn actually from this question. I hope it's clear. At least say yes, no, anything you can write actually. It's not like just sitting there. Be active so that I can uh, sense your presence. Na? I am just speaking. I am not getting any response from your side. This is actually, yeah, someone has replied. Third step. Okay, first step, second step, and this one is the third step. That's what you are asking. Third step is what we have to put. H is the maximum height. I have put the value of maximum height. U square sine 2 theta over g over 2g. Then the momentum. Momentum is what? Mass into velocity. This is linear momentum. Mass of the particle is m, and the velocity at the highest point means that particle is not moving in the vertical direction. So it has only horizontal component. And horizontal component is what? U cos theta, where u is the initial velocity. So m u cos theta. That's what we have put. I think all clear. Okay, moving further. So there is another question on your screen. This is a good question. Two small balls A and B. First of all, read the question with me, along with me. A and B, each of mass m, are attached rigidly to the ends of a light rod of length d. Just stop here. Don't study the complete question at one go. Take a break. What you have studied, just draw a rough diagram of that situation. So first thing that I have noticed that there is a light rod of length d. So I will draw that light rod. let's suppose this is the light rod. Light rod, it has no mass and it has a length d. Clear? And two balls A and B are attached at the two ends. Two balls A and B, these are the two balls A and B are attached, each of mass m. Everything is sorted till now. Okay. Now, the structure rotates about the perpendicular bisector of the rod at an angular speed omega. Now, again, take a stop. What is the perpendicular bisector? You will say, sir, perpendicular bisector will be something here, and the rod is rotating with an angular velocity omega about this point. Calculate the angular momentum of the individual balls and the system about the axis of rotation. So axis of rotation is this one. What I am saying, that this is the rod and axis is what? This one. So how it will rotate? It will rotate in this way, like this is. This is the axis at the center point, midpoint. I think it's blurred actually. You can understand. It's rotating like that. So I need to calculate the angular momentum. Okay. So now have a look at that again. Solution part. Let's suppose ball A and ball B. So I am taking for ball A first. In the previous class, I told you about how to calculate the angular torque about an axis. So just recall those things now. For ball A, I am calculating angular momentum. Let's suppose its angular momentum is L1. Is what? R perpendicular into P. Clear? It's clear now. It's rotating with an angular velocity omega. I am saying that it is rotating with an angular velocity of omega. Do you know that all these balls, only two balls are there. These two balls will also be rotating with the same angular velocity omega. This one with angular velocity omega, this one with angular velocity omega. Then, do you know or do you remember those things? If I say, just suppose this rod is like that, then it will revolve like that now. This is the center, the axis, and this ball will be rotating in this direction. This ball will be rotating in this direction, and it will continue to revolve like this. Then the linear velocity, V is what? V is what? We have learned that V is equals to R omega. This is a clear-cut relation. V is equals to R omega. So now, come here. What is R perpendicular? Can you see that line of motion of this particle is this one? This is line of motion. From the axis, the perpendicular distance is this one. If I draw a perpendicular from the origin or from the axis, it will be this one, and this distance is what? D by 2. So have you identified perpendicular, R perpendicular? This is D by 2. So we have placed the value R perpendicular is D by 2. R perpendicular is sorted. Now what is the value of momentum? You will say that momentum is mass into velocity. Is it okay with you? Mass into velocity. Now again moving further. L1 is D by 2 is here. Mass is here. And can you see that V is what? R omega. V is what? R omega. So what is the distance of this ball from the center? You will say D by 2. Can you see that? This distance is what? D by 2. So mass into velocity is what? R omega. R is what? D by 2 into omega. Now you can simply multiply all those terms. So L1 will be what I can see here, m will be here. It will become d square omega by 2. This is our angular momentum. The direction of angular momentum will be, we can calculate this direction. How can we calculate this direction? One thing is, I have told you that R cross P thing is what? From the center, this is R, this is P. Place your fingers, right hand fingers. What I think is that due to the mirror image formation, that when I am teaching you on a front based camera, that means my mirror image will be seen to you, so it might get confused, might create confusion in you. So I'm not doing that actually, because it might create confusion. According to me, this is R and downward is the P. I am taking my fingers, so thumb will be towards me. Towards me is coming outward from the paper. So that will be like that, outward. This is the momentum for ball A. Now, if I take momentum for ball B, can you see that ball B is identical to the ball 1 or ball A? So momentum, angular momentum will also be same. So it will be L2. I will write it directly. I'm not doing all those things actually here. So it will again M B square omega by, actually this is 2 into 2, 4 na? 2 into 2, 4. Very good. Nobody has noticed it actually. This is very poor from you. 2 into 2, 4. Okay. This is again L2 and it will again come in the outward direction. For ball A, we have calculated. For ball B, we have calculated. Now for the system. For the system, L is equals to L1 plus L2. All these angular momentum, L1 and L2 are in the same direction. So this will directly add. And if you add those terms, it will become M B square omega by, I'm not doing the calculation, basic calculations for you. This is the main thing. I hope you have learned about the angular momentum right now. Now, before moving further, I just want to ask you a few things. Angular momentum is the phenomena that is quite obviously seen during the Olympics, actually. Athletes use these concepts. So, our next concept, okay, someone has something to say. Left side, second step. Okay. Okay, left side, 1, 2. That's what you are asking? That's what now? Okay. So now listen. What is R perpendicular and P? We need to place these values. R perpendicular is the perpendicular distance from where? From the origin. So origin is what? This is our origin. Origin. Perpendicular distance on what? On line of motion. So at this point, I have drawn a diagram here that if you rotate the rod, then this ball will go like that and this ball will go like that. So the line of motion of ball A is this. This is the line of motion. And if you draw the perpendicular from the center, it will be this distance. And this distance is what? D by 2. Distance is what? D by 2. So R perpendicular is D by 2. P is the momentum. Momentum is what? Mass into velocity. This is linear momentum we are talking about. L is the angular momentum. So mass into velocity is what? In the next step, we have placed the value of velocity. Velocity is what? R omega. In this diagram, from the center, radius is what? D by 2. So V is equals to D by 2 into omega. That we have placed. D by 2 into omega, and after solving, it will become, after solving what? m d square by 4 into omega. Clear? Yasmin, I think I have pronounced your name correct. Yasmin. Okay. Is it clear now? Very good. So now moving further, conservation of angular momentum. Now, have a look at few of the things. What is the meaning of conservation of angular momentum? First of all, recall Newton's second law in translational motion. From there, we will get the exact situation. Newton's second law says what it says, that F net is equals to, do you remember now? Or I am just writing? I think you remember this thing. Rate of change of momentum. This is the Newton's second law. F net is equals to rate of change of momentum dp over dt. This law is applicable for translational motion. For translational motion. Now in rotational motion, we can also use the same formula, same relation with some different terms. So for rotational motion, what we can write, do you know that force is analogous to what? The thing that is done, that is performed by force in translational motion, is actually performed by torque in rotational motion. So force is equivalent to torque. So I am replacing this force with the torque. Torque is equals to, the momentum is replaced by angular momentum, that is dl over dt. So I am just reshifting, or you can say just changing the terms here from translational to rotational motion. Now, what if I say, if tau net is what? Net external torque is 0. This is again important term. If tau net is 0, then can you see that 0 is equals to dl over dt? That means dl over dt, what will you pronounce it? Rate of change of angular momentum. Rate of change of angular momentum is 0. That means angular momentum is not changing. If angular momentum is not changing, then you can say that L is constant. What can you say? L is constant. And if L is constant, can you say that L initial is equals to L final? If L is constant, that means L initial is equals to L final. And if L initial is equals to L final, then again we can conclude that L initial is what? I into omega. Initially, I will say it is I1 omega 1 is equals to I2 omega 2. So this is our golden relation. This is our golden relation. When it happens, when net torque is 0. When angular momentum of a system remains conserved, when net torque is 0, net external torque is 0. Now, what is the application of all these stuffs? Have a look at the slide, and on the next slide, there is an example. Have a look at that. There are two persons, और ये गिर जाएंगे मुझे लग रहा है. He will fall. This is suppose person A and this is Mr. B. So person A is revolving on a stool like this with a certain velocity, certain angular velocity, with his hand stretched like this. And person B has folded his hands. First thing that I ask you, what is the axis of rotation when he is rotating like that? Then you can say, sir, axis of rotation is this one. And I think this is not quite visible actually. I will place red color here. This is the axis of rotation about which the man is rotating. This is the axis of rotation. In the same way, axis of rotation is similar for this man as well. Now, one more thing. Can you see that the mass, the distribution of mass of this man A, is at a large distance from the axis of rotation as compared to this man? The maximum mass separation is this one. Can you see that the separation of the mass from the axis of rotation is more for the person A? And what we know that if I say I1 omega 1 is equals to I2 omega 2, according to you, this is for person A, this is for person B. Which person has more moment of inertia? Can anyone answer in one line, A or B? Which person has more moment of inertia about the axis of rotation? Anyone? I'm just checking the chat box here. Be quick. One, two, three, four. Moment of inertia is what? Moment of inertia is what? I is equals to m into r square. This is what moment of inertia. So if distance is more, then moment of inertia will also be more. So the person A is having more moment of inertia. Exactly. A. Very good, Yasmin. Person A is having more moment of inertia as compared to B. If I1 is greater than I2, can you see that I1 upon I2 is equals to omega 2 by omega 1 from here? If I1 is more, then omega 2 will be more. That means, just don't get confused. This is simple mathematics. If I1 is more, then the term opposite to it will also be more. So omega 2 will be more. That means person B will be moving with more velocity. Will be moving with more velocity. That's why when a skater wants to end his show, do you have you ever seen the skating show? The girl which is skating at the end, she just folds her hands and continue to roll like that, continue to rotate. How it is possible for her to rotate for a longer time? Because she just folds her hand, and by folding her hand, what she did, she just decreases her moment of inertia, and because of the moment of inertia is decreased, so its velocity increases and it continues to rotate. Now again, this is the same example. You have seen this example in the what? Olympics. This is a game of Olympics. So right now I am going to describe a simple question because time is just limited. So I'm just trying to add a concept test here. Okay, have a look at that. A wheel is rotating at an angular speed omega. Just don't read it W, it is omega, about its axis, which is kept vertical. An identical wheel. Now, have you imagined the situation that this is a wheel and it is just rotating about a vertical axis like that? An identical wheel initially at rest is gently dropped into the same axle. Now another wheel is also dropped here. So there is another wheel which is placed just over here. Now these are two wheels, one over the other, initially at rest, and the two wheels start rotating with a common angular speed. Find this common angular speed. Now, when we put another wheel, the friction will act between them. Listen to me very carefully. When if this is a wheel which is rotating, okay, I have placed another wheel which is at rest. This was rotating, so there is a friction between them, and due to the friction, ultimately it will slow down and it will start moving, and ultimately they will move with the same velocity. That's the situation is. Can you imagine there is a friction, but the friction is internal? Are you getting my points? Or I am getting just too upper level, going with some high level studies. It's a simple thing actually. You can imagine those things. Friction is there, and due to the friction, what will happen? The force of friction is internal. So the torque is also internal, and no external torque is there. So momentum will conserve. L initial will remain equals to L final. What is L initial? You will say L initial. Initially, there was only one wheel. Finally, there are two wheels. Are you getting my point? Initially, there is only one wheel. So what I can write, let's suppose the moment of inertia of the wheel is I and its velocity is omega. So the momentum is I omega. Clear? This is the initial situation. Now, finally, there are two wheels and both the wheels are identical. So the moment of inertia of the whole system will be 2I. If it's clear to you, then say yes. Moment of inertia of these two wheels will be 2I because they are two wheels rotating about the same axis, I and I, 2I, into, let's say, that angular velocity is become omega dash. If I cancel it, I will cancel out. So omega dash is equals to omega by, very simple question. Have you visualized the situation? Then there is another question on your screen. I hope you can do it on the what? As a homework. Okay, no, not this one. This is your homework. A very simple question. At least note it down because you are not doing the homeworks here. So I am giving you some time actually to note it down, and I am just ending the session after that. So in the last 1 minute, if you have something to say, you can ask me. Otherwise, I am just ending the session. If you are not able to find the previous lecture, that is lecture 4, then I am going to re-upload it on the YouTube on the same channel, Avanti Live 1. You can watch it there, and it's a very important lecture actually. So today I am going to upload it again if you face any difficulty. So right now I am just going to end the session. I hope you have written the question. So just ending session. Bye everyone. You have nothing to say? Okay, bye.
Hello everyone. Hello everyone. So today we are going to discuss about the complete 11J test discussion. The test that was held on the Saturday, and we are going to discuss most important question that is asked in the test. That is also very important regarding JEE and NEET also. So let's start the discussion, right? So if we see in the first problem, what is given? On a frictionless surface, a block of mass m at a speed v collide elastically with another block having the same mass. It is given information that which is initially at rest. And after the collision, first block moves at angle theta to the initial direction has a speed v by 3. Then the block second having the speed after the collision. So basically, if we see this problem, what is given in the problem, it is asked about that is very important information, frictionless surface. What is the meaning of frictionless surface? That mu equal to 0 here. And we consider that suppose if this block, that is say this block A having mass capital M, right? And this block is moving with a speed V and collide elastically. What is the meaning of elastic collision, guys? Whenever we are talking about the elastic collision, so we can say that in the case of elastic collision, total kinetic energy is conserved. So total kinetic energy that is conserved. So we can use this conservation of kinetic energy. It is asked in the problem to find the velocity of second block after the collision when the first block is moving with velocity v, and suppose see this is our second block that is also having same mass m, that is same as mass a. We can say this is the block b having the mass m, capital M, and this block is initially at rest. We can say that the initial velocity of block v is 0. What is happened after the collision? After the collision, it is given that after the collision, first block moves at angle theta. So we can say that after the collision, this is the situation before the collision, and this situation after the collision. Suppose that if after the collision, first block that is moved at angle theta with initial direction. This is the initial direction of motion. We can say that block A is moving in this direction. This is the motion of direction of block A after the collision, and this will make angle theta with initial motion of direction. So this is the velocity of block A after the collision. If we consider that block B is moving in this direction and say this angle is theta, this is the BB and this velocity is BB, we know that the conservation of linear momentum is also valid because no external force is acting here. So we can say that the initial total momentum must be equal to final total momentum. So initial total momentum in horizontal direction. So final total momentum also in only horizontal direction. That's why we consider that the block B is moving in this direction so that it can validate the conservation of momentum and also satisfy the momentum conservation, right? And in this problem, it is asked about that is the speed. Whenever in the physics, the speed word come, we have to think in the energy manner. Can we apply the concept of conservation of mechanical energy here? Let's think. So as we can say that if collision is elastic, it means it is a symbol to apply the kinetic energy conservation. So if we apply the kinetic energy conservation for the system, that initial kinetic energy equal to final kinetic energy. What is the initial kinetic energy, guys? That is the initial kinetic energy of the both the block. So we can say that is the half m v square. This is the block A. Block B is initially at rest, we can say 0. After the collision, what will happen after the collision? After the collision, it will become half mass, and that will equal to that VA is given after the collision speed of block is V by 3. If we put value V by 3 here, V square upon 9, and it is asked about what is the velocity or speed of block V. So let's consider that is the VV. So this will become half mv square. Mass is same. So we can say mass is cancel out, half m is cancel out from both the side. And here VV square, this can be written as V square minus V square upon 9. After taking the LCM, we can say that 8V square upon 9. So here we can say that the value of VV is nothing but 2 root 2 V upon 3. This is the magnitude of velocity, and we can say this is the speed of block V after the collision, 2 root 2 V by 3. So we can say option C is the right answer, right? I hope this is clear for everyone. Let's move further to the next problem. In the next problem, what is given? The least count of a stopwatch, that is 1 by 5 seconds, and time of 20 oscillation of pendulum is measured to be 25 seconds, correct? What is the maximum percentage error in the measurement? That is the basically question of the percentage error. And in this problem, the word least count is given. What is the meaning of least count here, guys? Least count is that smallest measurable value by any instrument. So in this case, this is measured for the time. So we can say that this is nothing but, guys, this is given that is the possible error in the measurement of the time. This is our delta t, and this value is given that 1 by 5 seconds. Whenever least count term is given, we have to think in this manner, that is the fluctuation in that reading that is given in the problem. The second information that is given 20 oscillation complete pendulum in 25 seconds. So what is the time taken to complete one oscillation? That is known as the time period. So we can say the time period, that is the time taken by pendulum to complete one oscillation. So in this manner, we can say that will become 20 upon 25 upon 20. Correct. So this will become 25 upon 20. So if we cancel this, this will become 5 upon 4 seconds. This is the time period. Right. What is the maximum percentage error in the measurement of time? So we can say that maximum percentage error at delta t upon t into 100, and this can be written as maximum percentage error. We can say that this value, this is written in this manner, delta t is 1 by 5, and we can say the value of t is the 5 by 4. If we divide 5 by 4, this will become 4 by 5 into 100. Here we can say this will become 4, and answer will become 16%. This is the value of maximum percentage error. Maximum percentage error 16%. Option D is the correct answer. So what is the information here? One is the least count, and second one is the how we can calculate the time period in number of oscillation is given. Let's go further. Next problem. That next problem, that is a very good problem that is asked in the mechanics section. Basically, in Newton law of motion, that is a uniform rod having length L, mass is m is given, and to an equal force where F1 is greater than F2, that is applied at across two ends of the rod, and it is asked about the tension in the rod at distance y from end A. Right. So guys, it is very much clear in this diagram. The rightward force F1, this is greater in magnitude as compared to F2. So we can say that the net force that is acting on this rod, the value of net force is nothing but F1 minus F2. If rod is uniform and the mass of rod is given, that is the capital M. So we can say that according to Newton's second law, F net equal to mass into acceleration. So we can say F net is nothing but F1 minus F2 that is acting in rightward direction. So this will become m into a. In this manner, value of acceleration that is written as F1 minus F2 upon m. Say this is the equation number 1, and we know that the direction of acceleration in the same direction of the net force, that is the rightward direction. So we can say that this is the direction of the acceleration. We have to find out the tension in rod at a distance y from end A. So this is the end A, and this is cross section V, where we have to find out the tension. Guys, whenever we have to find out the tension or any other force, just draw the FBD of the given segment. So we can say we have to draw the FBD of section, that is the section AB, right? So we can say that this section B, that is the attached with the left portion of CB, and we know that the molecules that beyond the point B try to pull the rod along the leftward direction. So we can say the tension due to this interatomic pulling, that is electromagnetic in nature, that is T. Let's consider the tension at this point in T, and this T force that is applied by the CV portion of the rod. If we want to draw the CV portion, guys, this is our CV portion, right? Yes or no? This section pull this section in this manner, and the same amount of force applied by this section, that is AB, and at point B in this manner by action reaction law. Okay. As we draw the FBD of this section, so if we apply Newton law of motion at section AB, what we can say that the acceleration of this part is also in the direction of the rod, that net force acting in the rod, right? So here, if we want to write down the net force, that F minus T equal to mass of this section. Say mass of this section is small m, that is small m into A. If we want to find out the value of tension, we can say this will become F minus MA. Firstly, we have to calculate the mass of this section AB. So we can say that the whole rod having length L, and the mass of unit length, we can say that want to calculate the mass of this Y length rod. So we can say this will become m by L into y. This is the small mass m of Y length rod, right, guys? So if we put this value, we can say in place of F, we can put F. Small m that can be replaced by m by L into y. And what is the value of acceleration from equation number 1? F1 minus F2 upon capital M. Just see the calculation, capital M and capital M which cancel out, and here T can be written as, guys, that this is nothing but that is the rightward force F1. So we can say that this is F1, that F1 minus F1 into y upon L, and this will become F2 y upon L. If we take F1 common, we can say this will become 1 minus y upon L plus F2 y upon L. If we see the option, so option A is the appropriately match with our solution. So we can say option A is the right one. Then what is the concept that you use in the problem? That is the basic how we can apply the Newton law of motion. If we have understanding how we can apply the second law of Newton law of motion, net force equal to m into a, we can easily solve the problem. And in this particular problem, we can also find out the tension at any given segment. Suppose if y equal to Ly2, Ly3, we can easily find out the value of tension. Let's move for the next problem. The next problem, what is given? That is the very good problem from motion in one dimension. and motion under gravity, it is given that a ball is dropped from a roof of a tower, say height h. So if we consider the diagram, guys, if we consider, suppose this is our tower, correct, and a ball is dropped from roof of a tower. A ball is dropped. So we can say if a ball is dropped from here, so we can say initial velocity of 0 and height of tower is given that is the small h. Total distance covered by in the last second of its motion. So what is the meaning of the total distance covered in last second? That is the concept of nth second. We can say that the ball is just going to collide the surface, and the total time taken by a ball, that is total time, if we say that is n. So we know that what is the formula, that distance traveled in nth second, that is nth u plus a by 2 2n minus 1. In this case, if we consider that total time taken to ball reach the ground surface, that is n, and initial velocity is 0, if we consider downward direction as a positive direction and upward, it will automatically become negative. This we can say that if we consider motion under gravity, so downward is positive, so we can say this will become 10 by 2 and 2n minus 1. And what is the value of s nth, that distance traveled in nth second? Okay, so this is our distance traveled in nth second. This will become 10n minus 5. Correct. Say this is the equation number 1. Here, this value is equal to distance covered by block in the first 3 seconds. What is the distance covered in the first 3 seconds? So we can say that the distance covered in the first 3 seconds, that is by using ut plus half at square. So we can say u is 0 here. So this S3 equal to half. If you put the value of g here, this will become t square. Here t, that can be, we can say that first 3 seconds, so we can say 3 square, and this value will become that 5, and 3 square, this will become 9. So this will become 45, correct, 45 meter. And in problem, this is say that this S nth must be equal to S3. So we can say that if we equate 10n minus 5, this will become 45. So here value of n equal to 5. So what is the value of height in meter? We can easily calculate that the distance covered in 5 seconds. That distance covered in 5 seconds. So we can say that S equal to ut plus half at square. This will become 5 square, that will become 25. And here this value will become 125 meter. We can say option A is the right answer. And we can apply the concept of the distance covered in a second and the simple that motion equation of motion. Next problem, that wave in a string having the amplitude 2 centimeter, wave travels in the positive direction of x-axis. That is the very informative, that wave travel in the positive x direction, correct. And with the speed of wave that is given, that speed of wave is given that 28 meter per second, and it is noted that it complete that 5 complete wave fit in 4 meter of length of string. So if we consider that in this problem, if we draw the wave in this manner, if we draw the wave in this manner, we can say that suppose this is the first complete wave, second complete wave, third complete wave, and in this manner fourth complete wave. And if we extend this, so we can say this is our 5 complete wave. And we know that the distance covered by wave in one wave, one complete wave is known as the wavelength. This is our wavelength, and 5 complete wave that is equal to 4 meter of string length. So we can say that this will become total distance, that is the 4 meter. Okay. So what is the value of wavelength here? We can easily say this will become 4 upon 5 meter, right? So velocity of wave is known, wavelength is known, and amplitude that is given 2 centimeter. If you convert into meter, 0.02 meter. Whenever wave is traveling in positive x direction, we can say that the sign between omega and we can say kx, that is always negative, and the general equation of wave, this can be written in this manner: a sine kx minus omega t. If wave is traveling along the positive x direction, then the coefficient of time and that is the displacement along the string having a negative coefficient, we can say that this will must be in opposite sign. That's why we can put this negative and this will positive, because wave is traveling along the positive direction. If we put the value of k, so k is known as the wave number, that is the 2 pi upon lambda. If we put this value here, k, this will become 2 pi upon a lambda, this will become 0.8. And the value of k, this will come 7.85 meter. What is the value of omega? That is the 2 pi f. And we can say that f, that is the frequency, this is nothing but velocity or speed of wave upon a lambda. So in this manner, if we put the value, this will become 128. For value of lambda, that is the 0.8. So in this manner, this value of omega, this will come 1005. That is radian. We can say radian per second. So in this manner, if we put all these value, what we will get 0.02 sine. In the place of k, put this value 7.85 x minus 1005 t. So we can say that easily seeing the question, we can eliminate two options, because positive sign is not possible here. Between the two terms x and t, positive sign is already eliminated. So there is only possibility either option C or option A. So we can say that after calculating the value of k, we can directly tick the answer. That correct answer is option C. I hope this is clear. Let's move further. Next problem. In this problem, again, this is the problem it is asked from the Newton law of motion, and that is the application. That again very good problem, that is string and pulley concept is also applicable in this problem. And what is given in the problem? In the problem, it is given that there are two blocks that is supported by a string pulley arrangement. Say this is block A, this block is B, having mass 2 kg, and that support another block C that is placed on an inclined plane, and the angle of incline that is given 30. We have to find out the magnitude of the acceleration of the 4 kg block. Correct. If we want to calculate the magnitude of acceleration, and whenever the question of Newton law of motion is come, firstly we have to draw the FBD. So if we draw the FBD guys here, what we can say that if we draw the FBD of block A, simply FBD of block A. FBD of block A, we can say that in this case, if we consider the value of G at 10 meter per second square, we can say 2G. 2G is acting in downward direction. In further calculation, we can put the value of G also. And we know that the tension is always away from the body. So that tension T is acting in this direction. Say this tension is that is the T1, correct. And we can say that this tension is transferred here. So this tension is T1 here, right? In this manner, if the tension in this string we consider that T2, so this will become also T2 here, correct. So if we draw the FBD of the block A, we can say 2D act in downward direction and T1 that tension that is acting in this direction, that is the T1, that T1. If we write the equation and we consider that body is moving in this direction, that 2G minus T1 equal to 2A. We know that all the blocks is connected with the string, so they must follow the string constants with the acceleration of all three blocks must remain same. So the acceleration we can say that this is the A. If we want to write down the equation for the block B, so what we can say that in the case of the block B, that T2 is acting in upward and again 2G is acting in downward. Because the system we consider that moving in this direction that with the acceleration A, we can say this is moving in this direction in acceleration A. And because of the constraint, we can say 2 kg moving in upward direction with the acceleration A. So if we write the equation, so what is the value of the tension T2 here? We can say that T2 minus 2G again equal to that is 2A. Say this is the equation number 2. Next, we want to write down the equation for the 4 kg block. So we can say FBD of 4 kg block. We can say the T1 is acting here and block is moving, if we consider in leftward direction. One another force that is component of mg. We know that mg is acting in downward direction. So mg sine 30 that is acting in along the incline. If this angle is, we can say if this is the normal, so this angle is again 30 degree. And this is nothing but this will become mg cos 30 and this is the normal force. So this force will become mg sine 30. So g sine 30, we can say in this manner, if we want to write down the equation for the 4 kg block, we can say that T1 is acting along the incline, T2 up the incline, and the force is nothing but mg sine 30 also acting along the incline. So in this manner, if you want to write down the equation, we can say T1 and that value of m, that is the 4 kg. So this will become guys 4g. Value of sine 30 is 1 by 2 and minus T2 equal to, this is the net force, that 4 into A. Say this is the equation number 3. And if we see all three equations and we have to calculate the value of acceleration, then what we have to do? We have to eliminate T1, T2 and 3T. If we add all three these equations, we can say that after adding all three these equations, equation 1 plus 2 plus equation 3, we can say T1 is cancelled, T2 is cancelled. Here 4 kg and 2 kg, what we can say that in this manner, this will become 2 kg and this minus 2 kg also cancel out. The value of 2g equal to 8a. So here value of a, that is 2g upon 8. If we put the value of g, that is the 10. So what we can say that this will become 10 by 4 and this will become 2.5 meter per second square. That is the absolutely correct answer. Option B is the right one. Let's move for the next problem. What is the next problem? That is again the problem asked in the thermodynamic section, and here a diagram is shown. The two paths may be taken by a gas to go from state A to state C. The gas initially at state A and gas had to move at state C by two paths that is visible from this diagram. That one path is AB via BC and again is AC. It is given in the problem. In the process that QAB 400 joule of heat is added in the system and BC that is the 100 joule of system. So we can say first of all we have to write down the data that heat Q added in the process AB. Write down. If heat is added in the system, we consider the value of heat is positive. If heat is rejected from the system, then we have to take this value is negative. But in this problem, it is given that is added in the system, that is the 400 joule. And in the process BC, it is given guys that is 100 joule, right? The heat absorbed by the system in the process AC. In the problem, we have to find out what is the value of QAC. What is the thought process? How we can solve this type of problem? Firstly, we have to see whenever diagram in the PV coordinate is given, one thing we have to understand, we can already calculate the work done by the diagram. So we don't take tension about how we can find out the work done. It is already given in this diagram and we can find out the work done. And moreover, whenever this type of problem, just think about the thermodynamic first law, we can solve any type of problem. Whenever discussion of heat, internal energy and work is involved, just take in the help of the thermodynamic first law. What is the thermodynamic first law? That we can say कि heat transfer equal to, we can write down delta U plus W. Correct. This is the value. This is the thermodynamic first law. By using this equation, we can correlate internal energy, heat and work. In this problem, we have to find out the heat absorbed in process AC. So we have to find out value QAC. If we want to find out value QAC, just write down the thermodynamic first law along the path AC. So write down the equation QAC. This can be written as internal energy along AC and W along AC. Correct. And we can say this diagram WAC is easily find out. How we can find out? We can say the WAC nothing but that is the sum of this triangle, area of this triangle and this red triangle. So if you want to write down what is the WAC here, we can say that what is the area 1 plus area 2, right? Area 1, we can say this graph is clockwise, so we can consider this is the positive half. Base, this will become 2 into 10 raised to power 3. And height, this will become 4 into 10 raised to power 4. In this manner, this will become 40 joule. Correct? This is the value of WAC. For the, this is the result we have get by the path, that is AC for the area 1. What is the value of area 2? That is the rectangle length into width. So we can see this width will become 4 minus 2, 2 10 raised to power minus 3, and height that 2 into 10 raised to power 4. So in this manner, we can say this value will become 40 joule, and this will become here again 40 joule. So this will become 80 joule. If we put this value to QAC, must be written as internal energy change along the AC and 80 joule. If you want to find out the value QAC, we must calculate delta UAC, that internal energy along the AC. And we already know that internal energy is a point function that only depend upon the initial and final point. So we can say that if we want to write down the thermodynamic first law along the path ABC, so how we can write down? We can say that internal energy along the path AB. This can be written as QAB minus WAB. But this is the AB process isochoric, so we can say that work done along this path is 0. So we can say internal energy along AB, this must be equal to QAB because WAB is 0 and this value will become 400 joule. What is the internal energy along path BC? We can say we have to calculate work done in plot BC and work done in path BC. This can be written easily that area projected on PV diagram, that is the BC. So we can say that length into width. So this will become 6 into 10 raised to power 4 into what is the this gap, that 2 into 10 raised to power minus 3. So in this manner, this value will become, we can say 120 joule. Correct. So in this manner, we can say that delta UBC, this can be written as QBC minus WBC, and this value will become 100 minus 120. We can say minus 20 joule. So in this manner, we can say that internal energy that path AC must be equal to internal energy path AB plus internal energy path BC. So we can say that this value will become 400 minus 20. This will become 380 joule. Put this value in equation 1. QAC, this can be written 380 plus 80 and answer will become 460 joule. This is very good problem, and this problem gives a thought process how we have to think whenever the relation between the heat and work between among the internal energy is given and how we can solve the problem. Let's move for the next problem. What is given in the next problem? Again, this problem is come from the friction chapter. A plank, a box on it that is gradually raised. If the angle of this plank is gradually raised and the angle of inclination with the horizontal when reaches 30 degrees, the box start to slip. It means we can say this angle when block just start to slip. That is the maximum value of static friction, and this type of angle is known as angle of repose. This type of angle is known as angle of repose. So we can say this value is nothing but the angle of repose in the maximum value of static friction can be written as tan theta, and theta is here 30 degrees. This will become 1 by root 3. After solving this, we can say this is nothing but 3 root 3 upon 3, and if we put this value here, so we can say approximately 0.6. Correct. So what is the value of static and kinetic friction? So we can say our first value must be become 0.6. Two options already eliminated, option C and option D. And we already know the coefficient of static friction rate greater than the coefficient of kinetic friction. So we can already say option D is the right one. But in order to solve, we can solve this problem. Whenever block will slide down, we can say kinetic friction is A. And if we draw the FBD, we can say this is the mg, and this value is nothing but this value is normal. If this angle is theta, this angle is theta, and this component become mg cos theta. The component along the incline mg sin theta, and we know that the block is moving along the incline downward direction, kinetic friction in backward direction. So if you apply Newton law of motion here, we can say that mg sin theta, that mg sin theta must be written as fk. Kinetic friction rate is written as mu into n, and this will become ma. mg sin theta. What is the value of guys n here? That is mg cos theta, and this is mu k here because block is slipping over the plane, and this will become ma. So here value of acceleration, this can be written as g sin theta minus we can say mu kg cos theta. Correct. Here, if we put the value of theta and one another information that is given here, block is slipping and sliding down 4 meters in 4 seconds. So if we consider the block when it start the slipping, the initial velocity 0. So acceleration is constant from this equation. So what we can say that guys, we can say that the distance s equal to ut plus half at square. So we can say that 4 meters, this can be written as u is 0 here, and acceleration, the value of acceleration, if you take g common here, that is sin theta minus mu k cos theta. Correct. And t square, this will become 4 square, we can say 16. So here in this problem we can say that this will become 8 and 4 upon 8, 1 by 2. So this will become g. If we put the theta 30 degree here, so this will become sin 30, and sin 30 again 1 by 2, and cos 30, that is the root 3 by 2. So if we put the value of g, that is the value of g 10 here, and solving this equation, we can say the value of mu k, this can be written as value of mu k, this will become 1/20, and we can say that this value is written as 1/20, 1/20, and here we can say that mu k √3/2. This value, this can be written as 1/20 minus. So here, and minus that is 1/2. So after solving, we can say that the value of mu k we can write down here. What is the value of mu k? That value of mu k, after if we solve the value of acceleration, this will become 1/2 meter per second square. That s equal to ut plus half at square. So we can say here acceleration is 1/2. And if we put the acceleration is 1/2, this mu k will become, this will become a equal to 10 sin 30 1/2. Again, value of mu k, and this will become √3/2. A is nothing, 1/2. So again, if we solve clearly, this mu k, this will become 1/20 equal to 1/2, and mu k √3/2. So again, we can say that this will become 1/10 equal to minus mu k √3. After simplifying, we can say that mu k is nothing but this will become approximately 1/2 and 0.5. So in this manner, we can say that the correct option is the option D, and we can easily solve this problem by the observation. What is the observation? Mu s is always greater than mu k, right? What is given in the problem? A wire elongated by L units with a load W is hung from it. The wire goes over a pulley and two weight W each are hung at two ends. Elongation of wire will be. Firstly, it is given that suppose if wire is supported by a single wire, we can see that the weight W is here. This is the weight W. And if the material of wire having the modulus of elasticity Y, we know that what is the elongation that always written as W is the original length. If we consider original length of wire is L, WL upon AY. Right. This is the formula of elongation, that whenever elongation, it is asked that load into length upon AY. In the second case, it is given that this is passing over a pulley. Say this is the passing over a pulley, and that is supported at each end W. Correct. And we can say this is whole length divided into two parts. So this will become L/2, and this again become L/2. And modulus of elasticity is same in the both the cases. Say this is the case 2 and this is the case 1. So if modulus of elasticity is same, area is same, load is same, so we can say that elongation or change in length, that is the proportional to original length. So here, what is the elongation at one end? We can say elongation at one end, that will L/2. So what is the total elongation? If we talk about the total elongation, this will become L/2 or L/2, that we can say that is the again L. Correct. So here we can say that this value will actually equal to its original value, and the initial elongation that is given in the problem, that is L. So we can say that WL upon AY is equal to L, and the same value is also come here, that the total elongation because of the two wire, this will become L. So we can say option A is the right one here. Let's solve that is the very important section, and the problem asked in the thermodynamics second law, Carnot engine. What is given in this problem? That a Carnot engine whose sink temperature is given, that is 300 Kelvin. So if we temperature, this is the higher source temperature, this is the sink temperature, and this is given at 300 Kelvin. And efficiency of this engine that is given, guys, efficiency of this engine is given that is 40%. We know that the Carnot efficiency written as 1 minus T lower upon T higher. Here we can say that T lower upon T higher, this can be written as 1 minus Carnot efficiency. So whenever we have to find out the value of T lower upon T higher, we can directly apply this equation. In initial case, this is given 40%. So we can say this value is nothing but 40% means 40 upon 100. And this will become, guys, that 60 upon 100. So here the value of T higher, we can calculate what is the value of T higher here. So if we cancel out this value, this will become T higher, T lower into 10 upon 6. T lower that is given 300 and this will become 10 by 6. So we can say that this value will become 50, that is equal to 500. This is the value of initial temperature 500 Kelvin. This is the value of T higher. It is given that how much should be temperature of source to be increased to increase the efficiency of by 50%. Original efficiency is that 40%. If we increase the efficiency by 50%, then what is the efficiency? We can see equivalent of 40 plus 50. So this will become, we can say that this equivalent of efficiency, this will become 20%. So what is the increase in efficiency? If we say that final efficiency, original will be, that is the 50% increase in efficiency. This is the increase in efficiency. That increase in efficiency, we can say that this value will become 20% and the final value of efficiency will become, we can say that 50 plus 20, that is the 70%. If we put this value in the again equation number 1, so we can say that T lower is upon T higher, say T higher new, this will become 1 minus 70 upon 100. This will become 30 upon 100. So value of, we can say this will become 3 by 10. So new value of T higher, this can be written as 10 upon 3 into T lower. T lower is nothing but 300. And this value will become, that is the 100. And we can say this value will become 1000. Correct. So in this manner, we can say that this value will become, this value we can calculate here, the value of efficiency we can calculate here. This value, after the calculating, what we will get here, we can say this value will become, that new value of T higher, we can say that the new value of T higher, this will become, after solving this, 350 Kelvin. So what is the change in temperature of source? That initial value we can say that 500. So this will become 350 minus 500. That value will become 250 Kelvin. So option D is the right one from here. And we can see that the option solving which we can calculate the value here. What is the increase in source temperature? In this problem, what is given, that radius vector, we can say position vector is given, and we have to calculate the magnitude of velocity, and also we have to calculate the acceleration vector. Correct. So how we can say, whenever position vector is given here, how we can calculate, guys, that is velocity. Just differentiate the equation, right? If we differentiate this equation, this will become dr upon dt. So we can say that whenever this type of problem comes, just solve separately for x and y. If we compare this position vector, that this can be written r vector equal to xi cap plus yj cap. What is the value of x? 4 sine 2 pi t. What is the value of y? At 4 cos 2 pi t. Correct. So how we can say that what is the value of velocity? Complete velocity, this can be written as vxi cap and vyj cap. This is the velocity vector. How we can find out the value of vx? That differentiation of dx upon dt and vy dy upon dt. So if we calculate dx upon dt here, this can be written as 8 pi cos 2 pi t. What is the value of vy here? This can be written as, we can say that the differentiation of 4 cos 2 pi t, and this value will become minus 8 pi sine 2 pi t. Right, guys? So here we can say the value of velocity, this will become that x component of velocity, this will write down 8 pi cos 2 pi t, and the y component minus 8 pi sine 2 pi t. If we want to find out the magnitude, we just take the mod, and this will become, guys, if we want to solve, this value will become directly, we can say the coefficient of this square and this square, this will become 8 pi. We can say 8 pi meter per second. Option is the correct, but in this question it is asked about the wrong statement. I think in this problem there is something mistake in the given that options, that actually in this problem it is asked about the wrong. What is the wrong statement? But this is the correct statement. So we can say this is not our answer. Let's move further. Next option, path of the circle. Particle is a circle. How we can check the path? Just write down the x and y and try to set a relation about the trajectory. We can say if we observe this data, that 4 sine 2 pi t and 4 cos 2 pi t, what we can say that if we add both the equation, so what we will get, x square plus y square plus 4 square, and we know that this is nothing but this is the equation of a circle. This is the equation of the circle and having radius 4. So option B is also right here. Acceleration. In order to find out the value of acceleration, again we have to differentiate this and this. We can see the value of acceleration. This can be written as axi cap and ayj cap. Axi cap and ayj cap. So what we can say that, guys here, ax is nothing but this can be written as dvx upon dt, and ay this can be written as dy upon dt. Correct. So if we solve this value, just make a space, and if we solve this value here, what we can say that dvx upon dt, that ax will become, here we can say 18 pi and 2 pi, that is 16 pi square, and differentiation of cos 2 pi t, again this will become minus sine 2 pi t, minus sine 2 pi t. So in this manner we can see this is the value of ax minus 16 pi square sine 2 pi t. In order to find out ay, this can be written as dy upon dt, and dy upon dt, again we can say that dy upon dt is nothing but, guys, dy upon dt, this can be written as e minus 8 pi into 2 pi, and differentiation of sine 2 pi t, that can be written by chain rule cos 2 pi t. Again this will become 16 pi square cos 2 pi t. If we put this value in equation of acceleration, we can say acceleration is nothing but, if we put 16 pi square common here, we can say that this value will become sine 2 pi t plus cos 2 pi t, and that is the minus sign. We can put minus sign here. So this is value of r, that is the position vector. So we can say that this is the value of the position vector that is initially given in the problem. So acceleration is also in the direction of minus r. We can say that the acceleration vector is also in the direction of minus r. What is the magnitude of acceleration vector? That is the v square by r. We can say the acceleration of magnitude of acceleration, that is the a centripetal v square upon r. Here we can also justify this answer because the value of acceleration, that is the 16 pi square, and if we v square divide over r, here what we observed that this value will become same. So here all the four options are correct, not even single option is wrong. So we can say that actually there is a mistake in the problem. So what we can say that all the options are correct. All the options are correct here. Sometimes it is also mistake in the NTA also. So we have to careful when this type of questions is come. We have to mark more appropriate answer, and that the marks provided by NTA for the all the students. Okay. In this problem, in the previous problem, that is say that ki increase in efficiency of 50%. So this is the efficiency, that is the 20% change in efficiency. Here that is the mistake, that is the initial efficiency is 40%. So this will become 40 plus 20, 60%, guys. So we have to improve the given error, that is initial efficiency. We have to mention that 40%. So 40 plus 20, this will become 60%. So we can say that in place of 70, we have to put 60. If we have to put 60 here, so this will become 40 and this will become 4. If this will become 4, so here this value will become, that is the 750. So this value is 750 Kelvin. So in this manner, the option, that is the 250 Kelvin is come option D. Let's move for the next problem. In this problem, what is given that ki ice is 0 degrees Celsius, that is kept in a calorimeter whose water equivalent is given. Water equivalent is given and how much is supplied to evaporate the water. So what is given here? Ice is given here and we have to convert into vapor. Correct. How we can convert ice into vapor? We can say after supplying the heat. What is the stage? Firstly, ice that is converted into water, then water that is converted into vapor or gas. Okay. Now we know that the total heat given to the system, this can be break into three parts. First part, second part. What is the first part? That mass into latent heat of fusion, mass into latent heat of vaporization, and one other portion, that sensible heat that given to the system. So we can say that Q1 plus Q2 plus Q3 and Q4, that heat taken by the equipment, that is the water equivalent. So we know that if Q1 is the heat that convert the ice into water, that involve into phase change, that is nothing but M into LF. Q2 is the heat that change the temperature of 0 degrees Celsius water to 100 degrees Celsius, 100 degrees Celsius water. We can see the actually process is in this manner: 0 degrees Celsius ice, this will convert 0 degrees Celsius water, this will convert 100 degrees Celsius water, and again 100 degree water, that will convert 100 degree vapor or steam. Correct. We can say heat 1, heat 2, heat 3, and the fourth heat is the water equivalent. What is the value of Q2 here, guys? We can say this is the ms delta T. We can say this value is written as ms delta T, and the value of Q3, that can again m into latent heat of the vaporization, latent heat of the vaporization, and Q4, that is the mass into, we can say that the water equivalent, that is the change in temperature between 0 to 100, that is the temperature change. After adding 4, what we can say that the value of Q, this can be written as 20 into 80, and this will become 20 into 100 plus 20 into 540 and 20 into 100. This is the water equivalent, that mass into change in temperature. After solving these value, adding these data, we can say that this value will become 16400 calorie. So this is the required value of heat to convert 0 degree Celsius of ice into 100 degree Celsius of the steam. So we can say in option B is the right one. Let's move for the next problem. What is given? A ship is moving in the westward direction. So if we draw the coordinate, what is given in this problem? Two ship is given actually. In this problem, two ship is given. And what is given that one ship A that is moving in westward direction. So this is east, north, and that is the west and south. One ship A that is moving in westward direction, say the ship A, that is the speed that is mentioned 10 km per hour. Ship B that is the 100 km from the south of A. So this is the south from A. So we can say this distance we consider 100 kilometer. And ship B is moving in northward direction. So this is the ship B. This is moving in this direction 10 km per hour. Then after the time in the distance between the ship becomes shortest. Whenever the concept of the shortest distance has come, we just solve this type of question by the relative concept. And what is the relative concept? We have to make one particle at a rest. Suppose if we want to make particle A is at rest, particle ship A is at rest, then what we have to do? We have to add the velocity of ship in opposite direction at ship B. Ship B that is moving in this direction that 10 km per hour. If we add the velocity of ship A in velocity B in opposite direction, we can say this will become 10 km per hour. And both the vector having the same magnitude, so we can say this is the direction of resultant vector. And we can say after apply the relative concept, ship A will become in rest. We can say this is the direction of motion of ship B with respect to ship A. We can say with respect to ship A, right? So we know that this angle is 90 and both the vector that same magnitude. So this angle is 45, this angle is again 45. What is the meaning of shortest distance? That is the minimum distance. And the minimum distance we can say that if ship B is moving in this direction, this is the motion of ship B observed by ship A. If we drop a perpendicular, this is the shortest distance, this is the AC. So in this triangle, what we can say that AC is nothing but that AC can be written as this distance is 100 student, 100 sine 45, right? So AC that can be written as 100 sine 45, that 100 upon root 2. So what is the time calculate to this distance? Then we have to know that what is the relative velocity. What is the relative velocity? We can say the velocity of B with respect to A, that is nothing but that is the resultant of 10 and 10. And this will become 10 square plus 10 square, that 10 root 2. So what is the time? We can say the time is AC upon VBA, and this value will become 100 upon root 2, and this will become 100 root 2. So here we can say that after solving this, this will become 5 hour. Option D is the right one. What is given in the problem that in an adiabatic process, pressure of a gas is found proportional to cube of its temperature. What is the value of Cp upon Cv? That is also known as adiabatic index. Okay, guys, in this problem, we have to calculate the value of gamma, which is actually Cp upon Cv. Whenever this type of question comes, we just remind the formula. That is the three format of a formula. What is the three format? Whenever the first, if we discuss the first format, that P2 upon P1, we can say that this value is written as PV raised to power gamma equal to constant. That is the first format. Second format T2 upon T1 that can be written as V2 upon V1 gamma minus 1. And the third and last format T2 upon T1 that can be written as P2 upon P1 that gamma P2 upon P1 that can be written as gamma minus 1 upon gamma. Right. So here we can say that after seeing this type of expression, what we can say that in this problem it is said that the pressure of gas is found at proportional to cube of temperature. P is just proportional to T cube. So what we can say that we can say that T cube can be written as Kp and T can be written as Kp raised to power 1 by 3. Right. So here we can say that this value 1 by 3 must be equivalent to gamma minus 1 upon gamma. So here 3 gamma minus 3 equal to gamma. So here 2 gamma equal to 3. So gamma equal to 3 by 2. Gamma equal to 3 by 2. This is nothing but Cp upon Cv. We can say option B is the right one. So after if we learn all these three equations, we can easily solve the problem. Oh, let's move for the next problem. This is the problem of the Doppler effect. What is given? That it is given that a man that is stationary condition observe two train, and suppose one train, say this train, one train is leaving and another train that is coming toward the man. What is the number of beat heard by the man per second? Say this is the situation one, this is the situation two, and in this condition we can say the beat F1 and this condition that frequency F2. So what is the beat, guys? Beat is the difference of frequency observed by observer. We can say that is nothing but F1 minus F2 mod. And we know that what is the observed frequency by the observer. This can be written as again that original frequency of source, and this can be written V plus minus VO, V plus minus VS. What is the VO? That is the observer velocity. What is the VO? That is the observer, we can say observer velocity. What is the VS? That is the source velocity. Vs is nothing but source velocity, and V is the velocity of sound. V is the velocity of sound. Okay, guys. Here observer is fixed. We can say VO is 0 here. And we can say what is the value of F1 here. If train is leaving, so we can say observed frequency is less than original frequency. We can say V upon. If this is the less, we have to put positive sign here. V plus Vs. And Vs, that is the value of the source that is given, that 4 meter per second. Okay. And so we can put this value that is the 4 meter per second. Say this is the equation number 2. If we find out F2, what is the value of F2 here? Again apply this formula F naught V upon, we can say V minus 4 air. Right. So in order to find out the beat, we can say we have to take mod F1 minus F2. So this value will become F naught V, that will common, and this will become 1 plus 4 minus 1 V minus 4. After solving this, F naught is given in the problem, that is the 240, and V value, that is the velocity of sound, that is the 320, and this will become V minus 4, again V minus 4, and divide over V square minus 16. So after solving this, we can get 240, and again mod sign is already here. We can say positive value here, and this value will become 8 upon V square, and this value, this can be written as 320 square minus 16. So this will become 336, and 320 minus 16, this value, that 320 minus 16, we can say that that value will become 296. After solving this, we can say that this will cancel out by 8 and 296, and solving this we will get 6. that is the observed frequency we can get 6 hertz. Okay, so here 6 hertz is the right answer. After solving this, we can say option A is the right one. In this problem, what is the given that frequency of mass when it is slightly displaced? Whenever this type of situation, just think if both the spring is attached in series or parallel. If this combination, we can simplify this combination in this manner. If we say this is the fixed position, this is also fixed position, and if we put two fixed position at a same place, so this can be also replaced in this manner. Both the fixed position that is replaced by a single position, and say this is K1, this is K2. So it is very clear that both the spring is arranged in parallel. How we can shift this diagram in this manner? Because we know that the both the ends are fixed, and the fixed end that is placed together at a given point, right? So in this manner, what is the we can say K equivalent here? That's simple K1 plus K2. And we know that the time period is nothing but 2 pi m upon k equivalent. We can say the frequency that can be written as 1 upon 2 pi k equivalent upon m. So value of frequency, this will become 1 upon 2 pi k1 plus k2 and divide over mass. So we can say which option is the correct. That option B is the right one. Again, what is given? The mass of 6 kg that is falling vertically with a downward support a mass 4 kg, a light spring passing through a pulley. So this type of situation is again given. This is the block having supported a mass 4 kg and 6 kg. And this is given that the mass 6 kg. Let's say this is the 6 kg falling downward, and say this is the 4 kg. Suppose this is the mass, this is the end point 4 kg that is moving in upward direction, and the situation that at 5 second string will be. So at 5 second, what is the distance covered by the 4 kg in upward direction? That is the same that 6 kg that cover in downward direction. See condition, this is the distance covered in 5 second. This is the 6 kg block. And the same time we can say this is the distance covered by the 4 kg block before breaking the string, and this is the initial position. Okay. So what is the acceleration in this case? We can say net force upon a mass. So we can directly say that the net force is 6g minus 4g upon 10. And this will become 2g upon 10. So this will become 2g upon 10, that is equal to 2 meter per second square, right? So how much high the 4 kg block will go? Suppose if the string is black at this position, whatever velocity attained by 4 kg block, the same velocity at 5 kg in 5 seconds, 6 kg in 5 seconds. We can say due to this velocity, this block will move in upward direction, right? Acceleration is given. So we can say that what is the velocity that is achieved in 5 seconds, that v equal to, we can say u plus 80. So we can say what is the a, that is the 2 into 5 seconds into 5. So what is the value of v here? If we say this value will become v equal to 10. Okay, this value will become 10 meter per second, and the height that achieved by 4 kg after breaking the string, v square upon 2g. So we can say this value again will become 10 into 10 into 2 into 10. So here this value will become 5 meter. What is the correct answer of this problem? That is the 5 meter. That is the last problem. The particle is thrown with the initial speed. This is the problem of ground to ground projectile. The particle is projected in this manner. The initial velocity that is given 50 meter per second, and the angle, this is the 53 degree, correct? And what is the given that what is the angle made by the direction of velocity 3 second, 4 second, and 5 second? So if we break the component, what is the ux? We can say 50 cos 53. This value will become 50 into cos 53, nothing but that is 3 by 5, and we can say this value is the 30, this value is the 40. What is the half time that block will reach at top point, that uy upon g. So after solving this, what we can say, this will become 40 upon 10, that is the 4 second. We can say 4-second particle having only one velocity, that is the horizontal velocity, and this is the time taken by the particle. So what is the angle made by particle at 4 seconds with the horizontal? That direction of motion is parallel to horizontal axis, that is the 0 degree. So we can say at 4 seconds 0 degree. So this is the time 4 second particle is at this position. So we can say 1 second before, that is the 3 second particle is something here, and at 4 second particle is something here. 5 seconds because of the symmetry. So if we calculate at 3 seconds, again see the diagram, at 3 second particle is somewhere here, and say this angle is theta, and say this is the Vy, this is the Vx. And one very important parameter in projectile, that horizontal velocity always remains same. So if we consider after 3 seconds, what is the vertical velocity? Vy equal to uy minus gt. So uy is nothing but that is the 40. If we take the value of g 10, so this will become 10 meter per second. And we know that vx equal to ux, that is equal to 30. So again we can say that angle theta made by the velocity vector from horizontal tan theta, this will become 10 upon 30, that is 1 by 3. So theta is nothing but tan inverse 1 by 3, right? We know by symmetry particle is at t equal to 3 second at point A, and this is the t equal to 4 second, that is the point of symmetry. The particle at after 5 second, that is at this point, and because of symmetry we can say the same angle made by particle but in opposite sense. We can say the theta is nothing but a minus tan inverse 1 upon 3. So in this manner, option A will correct. Option A is correct here, right? So guys, these are the some important question of the previous test. I hope all the questions is clear to you. Thank you so much.